An unexpected phenomenon has been detected in the sky of an alien world. And this is the image of an artist's impression of a giant glory shimmering on WASP 76b by ESA. A world famous for its hellacious conditions may have just been seen spotting one of the prettiest phenomena ever to grace Earth's own atmosphere, high up in the metal-filled skies of a world named WASP 76b. Astronomers have found evidence of a shimmering, multi-hued halo of light known as a glory. This spectacle has ever before been seen outside of the solar system, and within it only on two worlds, Earth of course, and then Venus, consisting of a series of concentric rings around a bright center. These gorgeous displays of color require specific conditions to form. Light needs to shine on a mist of spherical droplets that are all more or less the same size. Its appearance on WASP 76b can therefore tell us something about the mysterious atmosphere of this very alien world. There is a reason no glory has been seen before outside our solar system. It requires very peculiar conditions, said astronomer Olivier Demangion of the Institute of Astrophysics and Space Science in Portugal. First, you need atmospheric particles that are close to perfectly spherical, completely uniform and stable enough to be observed over a long time. The planet's nearby star needs to shine directly at it, with the observer, here Cheops, at just the right orientation. WASP 76b is a favorite for planetary scientists. It orbits a yellow-white star a little bigger than our Sun in the constellation of Pisces, some 640 light-years from Earth. Its orbit around the star is incredibly tight, whipping around in just 1.8 days. That closeness means it's also incredibly hot, with dayside temperatures exceeding 2,400 degrees Celsius, thus 4,350 degrees Fahrenheit, being hot enough to vaporize iron. There are literally clouds of the element in the exoplanet's puffy atmosphere. WASP 76b is 90% of the mass of Jupiter, but around 185% of its size. As the planet passes in front of its star, astronomers are able to peer into its atmosphere. So far, in addition to iron, they've identified sodium, calcium, chromium, lithium, hydrogen, vanadium, magnesium, nitrogen, manganese, potassium, and barium. That's one of the most looked at worlds in the galaxy. And in all this peering, astronomers have noticed something strange about the exoplanet's brightness. In data collected by European Space Agency ESA's in data collecting the European Agency exoplanet satellite Cheops, researchers noticed an excess in brightness in the eastern terminator, the line that marks the boundary between night and day. This is the first time that such a sharp change has been detected in the brightness of an exoplanet, Olivier says. This discovery leads us to hypothesize that this unexpected glow could be caused by a strong localized and anisotropic detectionally depending reflection, the glory effect. The signal is very faint, and further work will be needed to confirm that a glory is indeed what we're looking at on WASP 76b. However, if it is, that will reveal something new about the composition of the exoplanet's upper atmosphere. With the effect being analyzed across 23 observations in 3 years, it's clear the spherical aerosol droplets must be consistently present in the exoplanet's clouds or replenished at a constant rate. And this in turn requires stable long-term temperature conditions in the atmosphere of WASP 76b. If the phenomenon does turn out to be an enormous glory, scientists will need to model the world's atmosphere to work out what condition supports its presence. The discovery could have more far-reaching implications too. Positively identifying a glory on WASP 76b would give scientists a blueprint to search for the same phenomenon on other exoplanets, and being able to narrow down changes in light could lead to the discovery of other features such as starlight glinting of liquid oceans and lakes, the way sunlight gleams on Earth's oceans. Future observations are being planned so we can find this out. The research has been published in Astronomy and Astrophysics. This is by Michelle Starr on Science Alert. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.